Hello everyone, my name is Shovasis and my group member are Faisal Ahmed and Jayant Model. Today we are going to talk about cable control, underwater surveillance and research vehicle. In this presentation we are going to talk about background, motivation and objectives, problem statements and objectives, proposed system, design, simulation, hardware prototype and testing, also result analysis, addressing complex engineering problems and activities, limitations and conclusion, also future work. Background and motivation. Over the half century, ROV vehicle underwater have taken huge place for conducting research and doing difficult tasks. Remotely operated underwater vehicle or ROV are underwater robots that are used in science, entertainment, military and offshore oil industries. It can capture HD images. Also, through this ROV we can do environmental cost monitoring, habitat monitoring, pollution assessments. It can also help by doing underwater optical cable inspection and monitoring in all weather conditions. We also can do research underwater in areas causing harm. This machine was first used for industrial purpose for oil and gas purposes. Here we can see a picture of first prototype of ROV of US Navy. Literature review. We have studied a lots of journal and conference papers for this literature review. Here we can see 6 papers, their outcomes, limitation and also proposed solution according to our project. Problem statement and objectives. After go through all the papers, we have found some major problems like communication range is not large, so it is very difficult to control. The structure is very large, so it is very heavy to use. It can also record video in low light. Some of them are complicated and very hard to implement. Also, the important instruments are missing. Our proposed solution are less expensive, commercial grade materials and light weight as possible. Our ROV is simple and smart and cost-effective control system. It can also reduce the energy consumption and will be run in weather and any weather condition. Proposed system. Here is our proposed system design of our ROV. Basically, we have separated this in two parts. The left side is controlling part of the ROV and the part will remain on the ground. The right side is the main part of the ROV and this part will remain in underwater. In the ROV, we will use some motors for movement of ROV, light, temperature sensor of ROV gripper which will connect with the controller board, and also a camera which will connect with the smartphone directly. With the help of camera, we can control our ROV easily. This processor and the controller board are connect together with copper. Now I would like to call Jayant to continue this presentation. Thank you everyone.
Thank you, Shovasis. There are all the complex engineering problems like depth of knowledge of designing of CAD software, sensor system, optical fiber communication, then hydrodynamics, then range of conflicting system development can also lead to conflict technical and engineering. Then develop depth of analysis, no unique design. Then familiarity issues, unknown non-linearity, hydrodynamics effect, parameter uncertainty, then extended of applicable course beyond code of practice, then stakeholder involvement, university student and our own group member, then interdependence, vehicle tools, sensor control, display console, electrical power distribution, then threader cables handling system. Next slide. Then the complex engineering activities, range of resource like money, people, plastic materials are used for framing. Underwater technology and information are collected, electrical equipment are used. Level of interaction, sensor, then light system, control system, innovation, boundary principle and hydrodynamics, depth water locations, then familiarity issues were hydrostatics, hydrodynamics and boundary system. Then here you can see the body design of our ROV, which is designed by SketchUp Pro software. In backside we will use 2 motor and in front hole we have used 1 motor, which will help to up and down of ROV. Inside the ROB, you can see we will put all the electric components and wire except the motors and camera. Then the internal circuit design of our ROB, and the circuit is designed by EEE400 software, which is free. The microcontroller we will use the Arduino Uno R3. We have separated the total circuit in two parts. In left side we have used two joystick which will provide Arduino Uno analog data. In the right side we have used three brushless DC motor. The BLDC motor will provide 10 kilovolt, 10,000 volts. That's why we need to use external module called ESC or electronic speed controller. Then to power up all the electric parts, we have used 11.1 voltage lithium-ion battery. Then simulation. Here is our Proteus simulation for our project. The main purpose for this simulation is that making the PWM signal for all motors with exact frequency, and motors can run perfectly in physical environment. We also add temperature sensor with a LCD display, and all those things is controlled by Arduino Uno. A necessary component like BLDC motor, servo motor, ESCA or electric speed controller, temperature sensor, camera, microcontroller, LCD display, smartphone. Then power source is 11.1 3 cells lithium-ion battery. Then a good plastic frame for the ROB. Hardware prototype and testing. Here is our hardware prototype of ROB. You can see we have finally made it. From the first picture you can see that when we put into water it basically floats in water, but when we turn on the middle motor of the ROB with full speed, then the body going down slowly. We also add a gripper in front of this which can take materials from water, and it works perfectly. We also have camera sample photo in water. The picture looks like this because the water was dirty. Here we have add a prototype testing video also. So thank you. Now Faisal Ahmed will continue the presentation.
Thank you, Janta, for giving your part. Now I'm going to talk about the result and analysis of our project. So in our result analysis part, we have perfectly implemented the PID and ADA control, and the PID which we have used is used in a very smart way so that we can use it much more in an efficient way. So, and we have also perfectly implemented and used the PWM signal for running each BLDC motor, and that chart is also given to our slide. And when we are doing our result and when we are analyzing our result in our field and in our simulation, we have didn't find any kind of system loss or power loss during the simulation or the field testing, and there was no stability problem for the BLDC for the motors. So each of these details and each of these diagrams are given in the slides. Now the next result analysis part is the SolidWorks simulation. So what we have done the each side of simulation in a very different way by using the SolidWorks software. As example in here, the first one is the pressure testing and measuring of the SolidWorks from the left and right side. So it is basically the same, but we have shown the figure from the left side. And here we are saying that there are no big amount of pressure on the body part of our machine, because we can see that the light blue color are indicating that there are not much more pressure, but there are some indication on that on the middle of the part, and because of that the battery is actually there, and as it is very heavy part, so that's why the water pressure is much more excess in that part. On the right side you can see the pressure testing part, water testing on the bottom side of the SolidWorks. So in here the white part is basically indicated that these are the things that are helping and creating buoyancy force, so that the machine is actually not having that much pressure. but it is facing pressure to the left and right side of the bottom corner. In the next part, we have actually shown the full body pressure and dynamic testing in SolidWorks. In here we can see that in x-axis, it is going to the x-axis, and the pressure and the water pressure is not actually causing any harm, or it is not actually doing something that it forcing the vehicle to the other side. And there is a circle at the end of the machine, and it is indicating that the pressure actually is from the BLDC motor, and it is actually forcing the vehicle to the upward. And the whole scenario is being, and the whole dynamic testing is being done by the software, and we didn't find any kind of any unusual activities or any kind of error in our simulation. And we have given the data to a simulation by using the density of that material, as such as if we talked about that we have used a hard plastic material. So in the software we have given the density of the hard plastic material, and we have used some calculation about the buoyancy forces, and by using this kinds of thing we actually plot the diagram, and the whole data is on the left side, and as we can see that there is not very much amount of pressure, but almost 50.6 pascal to the each square centimeter of the vehicle. So now the result analysis of our data transmission. So in the first left picture is actually from the underwater footage from our VGA camera. So it is actually, the picture is very blur because the water is not clear, and we didn't find any water source that are clear in underwater, and it successfully have sent us the data from the underwater. And we also received receiving the video transmission. We just take the snapshot from that video and we just put in there, but we can actually take photos also, and that photo is on the left side of the slide. We can see the nighttime footage from the VGA camera. That was actually, when we took that photo, it was actually almost evening, and it was dark, and by using the light we can take the footage from the underwater by taking snapshots by our help of the camera. So now the impact of the project and environment and sustainability. So when we are doing researches on our project, we actually find very interesting thing, and we have put all the data and we summarize in our slide. As we can see that by doing this project we can actually improve the efficiency, and we can increase the sustainability, as this machine didn't harm any kind of natural, it didn't cause any harm to the natural environment, it doesn't harm the species which live under the water, and as the most important thing, that it doesn't use any kind of fossil fuel, and because of that the underwater remain clean and the environment remain very clean. And we can actually follow, and we can actually implement the sustainable development goal 6, which is actually clean and sanitation water. It doesn't harm our water sources. Now 8 is the decent work and economic growth. This project is a $1 billion market, have $1 billion market worldwide, and by doing researches we have find many interesting things, that in near future to almost 2030 it will be the main source, it will be the main machine to find much more energy from the sea or underwater doing researches. And by doing this the industry will be grow, and people will get jobs, as engineers will get more jobs, and there will be much more research center for developing this machine. So it actually also fulfill the desired goal of SDG 8. SDG, and the most important is the SDG 14, the life below underwater. So before of this project, it was actually very difficult to do things by using this kinds of, by using conventional method, it actually harm the species under the water, but doing this we can actually save them. On the left side is the energy consumption rate. In 2010 this machine was not actually used on that much, so the level of are very high. Now we can see the chart, every details are given in the slides. So now the impact on the project and environment and sustainability. It can actually, by using these kinds of machine more and more to our environment, it can actually reduce the carbon consumption almost 3% worldwide. As it is a very eco-friendly battery system and power supply, it doesn't harm any kind of our battery or the species, and it will encourage the local researcher to do more local research on that, and they will understand the underwater environment much more good. Seabed investigation, marine life studies, water and sediment sampling will be also done by the help of this project, so it is a very good thing. Now the limitation of this project was not a very much, because heavy lifting and this machine doesn't have the capabilities of heavy lifting. Battery life is limited because of underwater condition. ROV is very slow, we have to make it very fast, and it needs much more theoretical explanation about the hydrodynamics and marine engineering system. And the navigation and positioning sensor, implementing navigation and positioning sensor are also hard. Future scope are much more larger than any other project. By this, utilizing onboard power ROV, we are actually acquiescing the transmitter and receiver, exemption and implementation and simulation study. The future will see the trend of inspection class ROV in near future. It will enhancement the power technology. Conclusion: so the state of the art inspection class we have been done. Complexity and capability is also were followed. Data rates was 500 to 100,000 megawatts. Energy was efficient. Power system was been introduced. Simulation was design and analysis. Numerous opportunities for data transmission. And the last one is we have also successfully published a conference paper on the 12 ICC computing in network technologies, organized by IIT Nagpur, and the sponsor was IEEE. Thank you so much for listening. Thank you.